Hello there, welcome to Ethio-Hahu tutorial. I'm Getachew and today I'm going to discuss about graphs of logarithmic functions. Last time we have seen about logarithmic function and today we are going to see about graphs of logarithmic functions. Let a is greater than 0 and a is different from 1. Y is equal to logarithm of x to the base a. Therefore, how can we draw the graph of this y is equal to logarithm of x to the base a? Since a is greater than 0 and a is different from 1, y is equal to logarithm of x to the base a. The function y is equal to logarithm of x to the base a has no y-intercept because this function cannot be defined for x equals 0. Y-intercept is obtained when x is equal to 0. But when x equals 0, this function is undefined. Therefore, for x is equal to 0, y is not defined. That's why the function has no y-intercept. X-intercept, y is equal to 0. This implies 0 is equal to logarithm of x to the base a. And this implies x is equal to a to the power of 0 from the relationship between exponential function and logarithmic function. Logarithm of x to the base a is equal to 0 means a to the power of 0 is equal to x. A to the power of 0 is 1. Therefore, x-intercept is equal to 1. The other property, when x approaches to positive infinity, y approaches to positive infinity. And when x approaches to 0 from the right, then y approaches to negative infinity. Therefore, the graph 1, the x-intercept is 1. The function has no y-intercept. When x approaches to positive infinity, y approaches to positive infinity. The graph increases. When x approaches to 0 from the right, from this, y approaches to negative infinity. This is y is equal to logarithm of x to the base a. Case 2, when a is greater than 0 and less than 1, y is equal to logarithm of x to the base a. How can we draw the graph of this function? Since y is equal to logarithm of x to the base a and a is between 0 and 1, again, to draw the graph of this y is equal to logarithm of x to the base a, we need to have x-intercept, the nature of the function for x approaching positive infinity and approaching 0 from the right. X-intercept, y is equal to 0. This implies logarithm of x to the base a is equal to 0, and this implies x is equal to a to the power of 0, which is equal to 1. Therefore, x-intercept is equal to 1. The function has no y-intercept, because for x equals 0, the function cannot be defined. Next, as x approaches to positive infinity, y approaches to negative infinity because the base is between 0 and 1. As x approaches to 0 from the right, y approaches to positive infinity. Having this, let's draw the graph. X-axis, y-axis, and this is 1. the x-intercept is 1, that there is no y-intercept. As x approaches to positive infinity, y approaches to negative infinity. As x approaches to 0 from the right, y approaches to positive infinity. Therefore, this is the graph of the function y is equal to logarithm of x to the base a for a less than 1 greater than 0. And this is a decreasing function. Having seen this, let's draw the graph of y is equal to logarithm of x to the base 2. To draw the graph of y is equal to logarithm of x to the base 2, first let's have table x and y for different points on the x-axis. Let's find y. When x is equal to 1 over 8, y is equal to logarithm of 1 over 8 to the base 2. This is equal to logarithm of to the power of minus 3 over to the base 2. This is equal to minus 3. This is minus 3. When x is equal to 1 over 4, logarithm of 1 over 4 to the base 2 is minus 2. When x is equal to 1 over 2, logarithm of to the power of minus 1 to the base 2, that is minus 1. When x is equal to 1, y is 0. When x is equal to 2, y is equal to logarithm of 2 to the base 2 is 1. When x is equal to 4, y is 2. Logarithm of 4 to the base 2 means logarithm of 2 to the power of 2 to the base 2, that is 2. And when x is equal to 8, logarithm of 8 to the base 2 is 8 is to the power of 3. Logarithm of 2 to the power of 3 to the base 2 is 3. And this is the table that shows the relationship between x and y. To draw the graph roughly, x-axis, y-axis, 1 over 8, 1 over 4, 1 over 2, 1, 2, 4, and 8. Minus 1, minus 2, and minus 3. 0, 1, 2, and 3. When x is equal to 1 over 8, y is minus 3. When x is equal to 1 over 4, y is minus 2. When x is equal to 1 over 2, y is minus 1. When x is equal to 1, y is 0. When x is equal to 2, y is 1. When x is equal to 4, y is 2. And when x is equal to 8, y is 3. The graph looks like this one. This is the graph of y is equal to logarithm of x to the base 2. Again, let's draw the graph of y is equal to logarithm of x to the base 4. X, y. When x equal to 1 over 8, y is equal to logarithm of 1 over 8 to the base 4. This is equal to logarithm of to the power of minus 3 over to the power of 2. From properties of logarithms that we have seen so far, this is equal to minus 3 over 2 times logarithm of to the base 2. And this is equal to minus 3 over 2. When x equal to 1 over 4, y is minus 1. And when x equal to 1 over 2, logarithm of 1 over 2 is to the power of minus 1. To the base 4 means to the power of 2 minus 1 over 2. When x is equal to 1, y is 0. When x is equal to 2, y is 1 over 2. When x is equal to 4, y is 1. Logarithm of 4 to the base 4, that's 1. And when x is equal to 8, logarithm of 2 to the power of 3 to the base 2 to the power of 2, which is equal to 3 over 2. Having this, let's draw the graph. X-axis, y-axis, 1 over 8, 1 over 4, 1 over 2, 1, 2, 4, and 8. Here, minus 1 over 2, minus 1, and minus 3 over 2. 0, 1 over 2, 1, and 3 over 2. When x is equal to 1 over 8, y is minus 3 over 2. When x is equal to 1 over 4, y is minus 1. When x is equal to 1 over 2, y is minus 1 over 2. When x is equal to 1, y is 0. When x is equal to 2, y is 1 over 2. When x is equal to 4, y is 1. And when x is equal to 8, y is 3 over 2. If we draw this graph, this is the graph of y is equal to logarithm of x to the base 4. But here, one thing that you need to focus is how the graph is close to x for different magnitudes of the base. When the base increases, what will happen to the graph? And when the base decreases, what will happen to the graph? In this equation, the base is 2, whereas in this equation, the base is 4. And here, the base is greater than this one. Therefore, as the base increases, the graph is close to the x-axis. This graph is closer to the x-axis than this graph. That is the point that I want to emphasize. When the base is large, the graph is close to the x-axis. In this case, the graph is far from the x-axis, whereas in this case, the graph is close to the x-axis. To draw the graph of y is equal to logarithm of x to the base 1 over 2, the subtable x, y. When x is equal to 1 over 8, y is equal to logarithm of x to the base to the power of minus 1. 1 over 8 is to the power of minus 3. To the base to the power of minus 1 is 3. When x is equal to 1 over 4, 2, 1 over 2, 1. When x is equal to 1, y 0. When x is equal to 2, y is minus 1. When x is equal to 4, y is minus 2. And when x is equal to 8, y is minus 3. Therefore, x-axis, y-axis, 1 over 8, 1 over 4, 1 over 2, 1, 2, 4, and 8. 1, 2, 3. Minus 1, minus 2, minus 3. When x is equal to 1 over 8, y is 3. When x is equal to 1 over 4, y is 2. When x is equal to 1 over 2, y is 1. When x is equal to 1, y is 0. When x is equal to 2, y is minus 1. When x is equal to 4, y is minus 2. And when x is equal to 8, y is minus 3. If we draw the graph looks like this one. Y is equal to logarithm of x to the base 1 over 2. But when you come to y is equal to logarithm of x to the base 1 over 4, y is equal to logarithm of x to the base 1 over 4 is to the power of minus 2. Again, let's have table x, y, 1 over 8, 1 over 4, 1 over 2, 1, 2, 4, and 8. When x equal to 1 over 8, logarithm of to the power of minus 3 to the base to the power of minus 2 is 3 over 2. When x equal to 1 over 4, to the power of minus 2, logarithm of to the power of minus 2 to the base to the power of minus 2 is 1. When x equal to 1 over 2, logarithm of to the power of minus 1 over to the power of minus 2 is 1 over 2. When x equal to 1, y 0. When x equal to 2, logarithm of 2 to the base to the power of minus 2 is minus 1 over 2. When x equal to 4, logarithm of to the power of 2 to the base to the power of minus 2 is minus 1. When x is equal to 8, logarithm of to the power of 3 to the base to the power of minus 2 is minus 3 over 2. If we draw this graph, x, y, 1 over 8, 1 over 4, 1 over 2, 1, 2, 4, 8, 1 over 2, 1, 3 over 2, minus 1 over 2, minus 1, minus 3 over 2. When x equal to 1 over 8, y is 3 over 2. When x equal to 1 over 4, y is 1. When x equal to 1 over 2, y is 1 over 2. When x equal to 1, y is 0. When x equal to 2, y is minus 1 over 2. When x equal to 4, y is minus 1. And when x equal to 8, y is minus 3 over 2. If we draw this graph roughly, y is equal to logarithm of x to the base 1 over 4. Therefore, in this case, the base of this graph is 1 over 2, whereas the base of this graph is 1 over 4. But for a less than 1 and greater than 0, the graph is close to that of the x-axis when a is getting smaller and smaller. In this case, this graph is closer than this graph. Therefore, in general, for a greater than 1 and a different from 1, y is equal to logarithm of x to the base a. The graph x-axis, y-axis, and here we have 1. The x-intercept is 1, and this graph, if we consider this point is 1. This graph is, say, y is equal to logarithm of x to the base a. This one is y is equal to logarithm of x to the base b, and this one is y is equal to logarithm of x to the base c. In this case, since this graph is close to the x-axis than these two graphs, c is greater than b, which is greater than a. But for a less than 1 and greater than 0 and a different from 1, y is equal to logarithm of x to the base a, y is equal to logarithm of x to the base b, and y is equal to logarithm of x to the base c. In this case, a is less than b, which is less than c, so that this graph is close to this graph, and this one is close to this graph than this graph. Therefore, for a between 0 and 1, the graph is close to the x-axis when a gets smaller and smaller. But for a greater than 1, the graph is close to the x-axis as a increases. And in this case, a, b, and c are less than 1 and greater than 0. But in this case, a, b, and c are greater than 1. And for c greater than b and greater than a, the graph of y is equal to logarithm of x to the base c is close to the x-axis than y is equal to logarithm of x to the base b, and y is equal to logarithm of x to the base a. And this is all about the graphs of logarithmic function. And next time we'll have another topic. Until then, have a nice time.